Hi everyone. Welcome to the video lecture series number 4 of electrical machines and drives. In this video lecture series, now we are going to discuss about the speed control of last class. We have discussed about speed control of AC motor, induction motor, and what is VFD. This and all we have discussed in last class. So now we are going to discuss about. So last class we have discussed about this. What is VFD and why it is. How the voltage is variable, etc. Now we are going to discuss about what is discuss in detail about what is VFD. Okay. So what is the main components of VFD? Here we are. The major three components are rectifier, bus bar, and inverter. Rectifier, bus bar, and inverter. These are the main three components. Here, what about rectifier? This rectifier convert AC to DC. Here, first we can say this AC supply is converted into constant DC supply. This rectifier process takes place from AC to DC. And next, DC bus bar. Here, the DC bus bar is transforming the DC supply from one place to another other place. That is DC bus bar. Next, inverter. Inverter convert this AC DC supply to AC supply, and that AC supply will have a variable frequency. So our main aim is to convert the fixed AC supply to variable frequency, fixed frequency to variable frequency. Here we can see here the frequency is constant. Here the frequency is variable. At the same time, the amplitude is also variable. Here these are the main three components of a variable frequency control drive. Okay, here the main components, one is rectifier, which convert AC supply to DC supply, and next one is DC bus bar, the transforming the DC supply from one place to another place, and next one is inverter, which converts DC supply to AC supply. Okay, now coming to VFD basics. So here we can see the block diagram of VFD. Here we can see the three-phase supply. Three-phase supply. This three-phase supply is given to converter, that is AC to DC, because with the available supply is AC supply. This AC supply is converted to DC supply. AC supply is converted to DC supply, and this DC supply transformed through DC bus bar and reaches the inverter and this inverter, we know that the inverter converts the DC supply to AC supply, and then AC supply is given to the load, whatever the load we need, whatever the motor speed we can control, because here the frequency, now the frequency is varied. So now the frequency is varied. But what happens? First, the frequency is constant. First the frequency is constant. Here the frequency is variable frequency. So if the frequency varies, automatic the voltage varies. If the voltage varies, supply varies, and the motor speed also varies. So these are all correlated with each other. Okay. So this is the basic VFD basics. This is a basic block diagram of VFD. Now coming to how speed is controlled using VFD. Example, rectifier. First process is rectifier. The rectifier in the VFD is used to convert the incoming AC supply to DC supply. So first process we can see that. So this is bidirectional supply to first DC, unidirectional supply, bidirection to unidirection signal. Okay. So the one rectifier diode will allow power to pass through only when the voltage is positive. It passes when the voltage is positive. We have already seen previous classes. It allows only when the voltage is positive. The second rectifier will not power to pass through only when the voltage is negative. If the voltage is negative, what happens? We won't get the output. We'll be getting the output when only the diode reaches the positive cycle. Okay, so this is the first process. Now coming to next, this is the first rectifier. Now coming to next processes. Coming to next processes. DC bus bar. This contain capacitor and inductor. It accepts the power from the rectifier and observe the AC ripples and deliver a smooth. Here what happens is the DC bus bar. So now here what happens is the unidirection, there's a unidirection supply. We in previous class you'll be learning about the unidirection supply in previous slide. What happens? This unidirection supply, the capacitor won't allows the signal to reach the zero crossing. Before it reaches zero crossing, what happens? The capacitor acts and gives the supply, and it will get the and we can deliver the constant DC supply, and we can deliver the constant DC supply. So this process takes place in DC bus bar. Okay. Now coming to inverter. What happens is, coming to the inverter. What happens? The inverter contains IGBT that inverts DC power supply into AC and delivered to the motor. Here we can see the delivered to motor. The IGBT can switch on and off several thousand times per second. We can see the ICs can switch on and off several thousand times per second. So per seconds, we just imagine several thousand times we can on off. Okay. So now the IGBT uses pulse width modulation (PWM) techniques to simulate the voltage sine wave to desired frequency. Okay, here we can the pulse width modulation technique. Here we are using pulse width modulation technique. Okay, now coming to coming to pulse width modulation technique, we have seen so many technique, square wave technique, whatever technique, but pulse width modulation technique is an efficient technique which mostly used in converting DC to AC inverter process. Okay, okay. With this, we can conclude this video. We can continue with this video by next class. Thank you so much.